Most people look at quartz and see nothing more than an ordinary white rock, something hard, something common, something completely worthless. But deep inside certain quartz veins, hidden beyond the surface, the Earth sometimes leaves behind one of the most valuable metals ever discovered: gold. And what makes this even more fascinating is that gold doesn't randomly appear inside quartz. There's a reason it forms there, a system behind it, a hidden geological process that begins far below the surface of the Earth, under conditions so extreme that entire landscapes are slowly reshaped by them. And by the end of this, you're going to understand how gold becomes trapped inside quartz rock, why some quartz veins contain nothing at all, and why certain places on Earth become natural pathways for hidden mineral wealth. Because this story is not just about gold extraction, it's about understanding how the Earth builds value in secret. At first glance, quartz doesn't look important. It's found in mountains, rivers, cliffs, even in ordinary gravel. In fact, quartz is one of the most common minerals on Earth, which creates a strange question. If quartz is everywhere, why is gold only found in a tiny percentage of it? The answer begins underground. Far beneath the surface, the Earth is constantly active. Heat rises from deep below, pressure builds, rock layers fracture and shift over immense periods of time. But these movements don't happen evenly. Certain zones become weak points in the Earth's crust. Faults, cracks, fractures extending downward into hotter regions below. And these fractures become something extremely important. They become pathways. Because deep underground, superheated fluids begin moving through these openings. Not ordinary water, but mineral-rich hydrothermal fluids, carrying dissolved elements from deep within the Earth itself. And hidden within some of these fluids are microscopic traces of gold. Now here's where things become incredibly interesting. Gold cannot simply travel through solid rock by itself. It needs a transport system. Under intense heat and pressure, these fluids act almost like underground highways, carrying dissolved minerals upward through fractures in the crust. But transporting gold is only the first part of the story. The real mystery is this: why does the gold suddenly stop moving? Why does it become trapped inside quartz? The answer lies in changing conditions. As these hydrothermal fluids rise closer to the surface, temperature and pressure begin to change. The chemistry of the fluids changes too. And when those conditions shift enough, the minerals carried inside the fluid can no longer remain dissolved. So they begin to separate. Quartz starts crystallizing first, slowly, layer by layer. The quartz fills fractures and open spaces inside the rock. And if gold is present in the fluid during this process, tiny particles of gold become trapped within the growing quartz vein itself. This is how gold-bearing quartz forms, not instantly, not randomly, but through repeated geological events occurring over immense spans of time. Sometimes the process repeats again and again. More fluids rise, more quartz crystallizes, more minerals accumulate, and over millions of years, entire vein systems begin forming underground. But here's the part most people never realize. Not all quartz veins are equal. Some contain absolutely no gold. Others contain only microscopic traces invisible to the human eye. And a very small number become exceptionally rich, which raises an important question. What separates ordinary quartz from gold-bearing quartz? The answer is structure, because gold formation depends heavily on geological positioning, the right fractures, the right pressure zones, the right fluid pathways. If the structure is wrong, the system fails. This is why experienced geologists don't just search for quartz itself. They search for evidence of a larger mineralizing system. A quartz vein alone means very little, but a quartz vein connected to fault structures, hydrothermal alteration, iron staining, sulfide minerals, and ancient fluid movement. Now that changes everything, because those signs suggest the Earth once had the exact conditions needed to move and deposit gold. And this is where observation becomes intelligence. To most people, mountains look random, but to someone who understands geology, landscapes begin telling stories. A fracture line cutting through rock might represent an ancient pathway for mineral-rich fluids. A rust-colored stain could signal oxidation from sulfide minerals once associated with gold systems. Even the orientation of quartz veins can reveal clues about the forces that shaped them millions of years ago. And suddenly, the land stops looking ordinary. It becomes evidence. But even after gold-bearing quartz forms underground, the story still isn't finished, because the Earth never stops changing. Over time, mountains rise and erode. Wind, rain, rivers, and temperatures slowly break rock apart. The material that was once buried deep underground begins moving closer to the surface, and eventually, exposed quartz veins appear. Some remain hidden inside cliffs or hillsides. Others break apart completely, releasing gold particles into rivers and streams. This is why gold is often connected to both quartz veins and placer deposits. The placer gold found in rivers frequently began inside quartz veins long before erosion transported it downstream, which means rivers sometimes carry the final chapter of a geological story that started deep underground millions of years earlier. Now here's where things become even more fascinating, because finding quartz is easy. Finding the right quartz is difficult, and extracting gold from quartz requires understanding what you're actually looking at. Sometimes visible gold appears directly in the quartz itself. Thin streaks, tiny specks, metallic flashes reflecting light from within the vein. These discoveries create excitement because visible gold is rare, but visible gold can also be misleading. Some quartz appears promising while containing almost nothing economically valuable. Other samples contain microscopic gold invisible without testing, which is why serious analysis matters. Historically, miners crushed quartz rock to release trapped gold particles. Stamp mills thundered endlessly, breaking hard rock into smaller fragments. The crushed material was then processed to separate heavier gold from lighter waste material. Entire mining towns were built around these systems. Because once rich quartz veins were discovered, everything changed. Economies shifted, people migrated, landscapes transformed. All because ancient hydrothermal systems once moved invisible traces of gold through cracks in the earth. And yet, despite centuries of mining, the process itself remains extraordinary. Think about what had to happen for gold-bearing quartz to exist. Deep heat within the earth, structural fractures, hydrothermal fluid movement, chemical transport, pressure changes, mineral precipitation, millions of years of geological activity, an enormous chain of events, all required for a single quartz vein to contain gold. And if even one part of the system failed, the gold never formed. This is why geology is not simply about rocks. It's about processes, invisible systems shaping the surface of the earth over immense spans of time. Systems that leave behind clues for those who understand how to read them. But perhaps the most fascinating part is this. Most gold-bearing quartz remains undiscovered, not because it doesn't exist, but because the earth hides it well. Some veins remain buried deep underground. Others exist in remote terrain few people ever explore. And some are overlooked completely because they appear ordinary from the surface. Which means somewhere right now, hidden beneath mountains, valleys, or ancient rock systems, new quartz veins are waiting to be recognized, waiting for someone to understand the geological signals connected to them. Because the real secret isn't simply finding quartz, it's understanding the system that created it. And once you begin seeing those systems, the landscape changes forever. A fracture becomes a clue. A vein becomes evidence. A mountain becomes a geological record of ancient forces still shaping the world today. But this raises an even bigger question. If gold-bearing quartz forms through specific pathways and hidden geological conditions, then how many valuable systems still exist, completely unnoticed beneath the Earth's surface right now?
Why do locals always seem to find gold where outsiders fail? It is not luck. It is not secret maps. And it is almost never because someone is hiding treasure intentionally. The real secret is far stranger. The richest small gold locations are often fully visible, crossed by hikers, fishermen, farmers, and travelers every day. Yet almost no one recognizes them as gold environments because they do not look like gold country. And locals succeed because they are not searching for gold itself. They are reading patterns outsiders never notice long enough to understand. Gold survives in these places precisely because they appear too ordinary to investigate seriously. Outsiders search for excitement. Nature rewards patience. Locals observe landscapes repeatedly across seasons. They watch rivers rise and fall, banks collapse slowly, gravel bars shift position year after year. Without realizing it, they gather geological data simply by living nearby. Time becomes their advantage. Gold movement is slow. Heavy particles respond differently to water than sand or gravel. During floods, lighter materials travel far downstream, while gold moves only short distances before settling again. This creates predictable concentration zones, but only visible to observers who notice gradual change rather than single events. A visitor sees randomness. A local sees repetition. One of the most misunderstood hidden gold environments forms at inside river bends that appear unremarkable. Water slows slightly as it changes direction, allowing dense materials to settle beneath layers of lighter sediment. These zones rarely sparkle on the surface because fresh sediment constantly covers them. Gold hides beneath calmness. Locals learn where seasonal floods remove just enough overburden to expose new material temporarily. They arrive at precise moments outsiders rarely witness. Timing protects the secret more effectively than secrecy itself. Another overlooked location lies where small seasonal streams meet larger rivers. During dry periods, these tributaries appear insignificant, sometimes completely dry. Prospectors ignore them because visible water seems necessary for gold transport. But during storms, these channels become powerful conveyors, carrying concentrated heavy minerals from narrow drainage zones. When water slows at the junction, gold drops rapidly. The richest material may accumulate within meters of the meeting point, hidden beneath mud deposited afterward. Outsiders arrive during calm conditions and see nothing. Locals remember what happens during rain. Human infrastructure unintentionally creates additional hidden gold traps. Old bridges alter water flow subtly. Support pillars create pressure shadows downstream where heavy materials settle. Generations pass without recognizing that engineering structures quietly reorganize sediment distribution. Fishermen standing nearby may unknowingly stand above concentrated gold. Gold does not care whether a structure is natural or human-made. It responds only to physics, velocity, turbulence, and gravity. Locals notice where gravel piles reappear after every flood. Consistency becomes evidence. Ancient river channels provide another secret layer. Many modern rivers no longer flow where they once did. Geological uplift and erosion gradually shift waterways, leaving abandoned channels buried beneath soil or farmland. These paleo-channels often contain gold deposited when rivers carried stronger flows thousands of years ago. From the surface, nothing appears unusual, but subtle clues remain. Rounded stones far from modern rivers, unusual soil coloration, or vegetation patterns reflecting buried gravel layers. Locals farming land for decades notice stones appearing repeatedly during plowing. What seems like inconvenience becomes geological memory. Gold survives where rivers used to live. Hillsides also hide gold in ways outsiders misunderstand. Erosion slowly releases particles from source rock above and carries them downhill through soil movement rather than visible streams. Gravity alone becomes the transport system. Gold accumulates behind natural obstacles, tree roots, exposed bedrock shelves, compact clay layers, forming slope deposits invisible to casual observation. Locals walking the same trails for years notice where soil washes away repeatedly after storms. These subtle scars in the landscape reveal concentration pathways. Gold follows persistence, not drama. Vegetation offers another hidden indicator rarely discussed openly. Certain plants thrive in well-drained, gravelly soils, while others prefer fine sediment. Changes in plant distribution can outline buried channels invisible from ground level. Locals recognize unusual vegetation lines because they contrast with surrounding terrain. To outsiders, it looks like random growth. To experienced observers, it marks underground structure. Nature signals through biology as much as geology. Old mining regions contain perhaps the most carefully guarded hidden spots, not because locals hide them deliberately, but because history itself hides them. Early miners targeted visible gold, and abandoned areas once easy deposits disappeared. Their tools limited depth and processing ability. Material discarded as waste decades ago often still contains gold concentrations overlooked by early methods. Locals familiar with regional history revisit forgotten locations where subtle clues suggest unfinished potential. Knowledge of human behavior becomes as important as knowledge of geology. Gold remains where expectations ended too soon. Weather patterns reinforce secrecy. Freeze-thaw cycles break rock gradually, releasing trapped particles each winter. Spring runoff transports newly freed gold short distances before depositing it again. Every year resets opportunity slightly. Locals understand seasonal rhythms intuitively. They return after specific weather events rather than searching randomly. The land changes quietly, while outsiders wait for permanent signs. Gold rewards those who follow cycles. Even sound plays a role few discuss. Experienced locals sometimes listen to how water moves across bedrock. Changes in pitch reveal variations in depth and turbulence, indirectly signaling potential trapping zones. What sounds like ordinary flowing water contains information about flow energy. Gold settles where energy drops suddenly. Listening becomes another observational tool. Urban edges hide surprising gold locations as well. Expansion of towns often covers historic waterways and gravel deposits beneath roads and parks. Construction exposes sediments briefly before covering them again. Workers occasionally notice heavy black sands or unusual stones during excavation. Locals remember these moments long after projects finish. Temporary exposure creates lasting knowledge. Gold does not disappear simply because cities grow above it. Psychology protects hidden spots more effectively than secrecy agreements ever could. Most people search where others are already searching. Crowds validate expectation. quiet places feel unpromising by comparison. Locals trust absence of attention as confirmation rather than discouragement. Where few people look, evidence remains undisturbed longer. Gold survives inside overlooked environments. Scientific surveys confirm an important truth. Gold distribution follows structural controls invisible at surface scale. Subtle fault lines influence erosion patterns and drainage alignment. These structures guide water movement for thousands of years, repeatedly concentrating heavy minerals along predictable corridors. Locals may not describe faults scientifically, but they recognize recurring landscape behavior. Streams aligning unusually straight, valleys forming consistent directions, or ridges breaking suddenly. Observation substitutes for terminology. Understanding emerges without formal geology. Temperature differences also matter. Sun-facing slopes dry faster after rain, allowing sediment movement to stabilize differently than shaded slopes. Gold migrating downhill often settles where moisture slows soil transport. Locals notice which slopes remain wet longest. Moisture patterns quietly shape mineral distribution. The greatest secret of all may be scale. Hidden gold spots are rarely enormous. They produce modest but consistent finds rather than spectacular discoveries. Because they lack drama, they escape attention. But over years, small consistent recovery surpasses occasional luck. Locals value reliability. Outsiders chase miracles. Technology has changed searching, yet local advantage remains powerful. Metal detectors and satellite imagery help identify targets, but interpretation still depends on understanding landscape behavior accumulated through experience. Data without context leads to misinterpretation. Locals possess context. They know where rivers flooded unusually decades ago, where landslides exposed fresh gravel, where drought revealed bedrock temporarily. Memory becomes geological evidence. Gold persists in these locations because discovery requires combining multiple subtle clues simultaneously: hydrology, erosion, seasonal change, human history, and patient observation. Remove any one factor, and the pattern becomes invisible. This complexity protects hidden spots naturally. Nature does not hide gold deliberately. It simply demands attention across time. And only those who remain long enough to witness repetition begin to understand where the real opportunities lie. Somewhere right now, along an ordinary riverbank or quiet hillside, known only to nearby residents, gold continues settling exactly where physics predicts, unnoticed by travelers passing through, overlooked by those searching for obvious signs, and waiting in places that appear too familiar to ever be considered extraordinary.